Yeah, me too.
Okay.
We're a little delayed.
There's going to be a delay, guys. This is across our entire country and an ocean. Because you're in the UK, right?
Yes.
Okay.
Yep.
Thank you for being here.
Okay, you're good.
We appreciate this. Students have some questions for you, so they'll stand up one at a time and ask you their question. I appreciate. Okay, sounds good.
Well, thank you for inviting me.
How old are you?
I'm 31. So I was born in 1985. A long time ago.
When did you know you wanted to study this or be a scientist?
So it took me a long time to know that I wanted to be a scientist. For a long time, I just studied science at university because it was my favorite thing. And so that's why I chose that in the first place. Yeah, eventually I finished my studies and I had some really good lecturers who helped me to start being a scientist in a laboratory. And so they taught me how to be a scientist in a laboratory, and then I decided that that's what I wanted to do.
And can I ask real quick, Dr. Moore, what is your title? Like, if you could just introduce yourself briefly before they ask a few more.
Yeah, sure. So I'm a doctor, but I'm not a medical doctor. I'm just called a doctor because I have a PhD, which is a university course that you do, and you get to be called doctor after that. And so my job title is research associate. So my boss is a professor, and I am one of his associates, and I help him do research. Does that make sense?
Yeah.
Okay, great.
How many different types of cancer have you looked at?
So when I was at university, we looked at some different types of cancer. I would say probably we learnt at about lots of different types. I would say probably 20 different types. But on my day-to-day research, I don't look at cancer very much, but instead I look at some other cells that we hope can help us learn about cancer, because they act in similar ways to cancer cells.
What is your most exciting discovery?
Ooh, well, so most recently I made a discovery that, so at the moment I'm looking at nerve cells. You guys heard about those?
Yeah.
In your brain and in your spinal cord. Yep. I made a discovery that's going to help us, I hope, understand how they make the shape that they end up as. So lots of people have already looked at that in a petri dish, but I'm looking at it using a zebrafish, and so I hope that that will give us even more information.
What time is it right there?
Right now it is 23 past 9 in the evening, so it's Monday night. Yeah, so I've already had my dinner.
Where did you get the idea to become a scientist?
So mainly it was from the lecturer, the really cool lecturers who I had, who I told you about before, and they helped me to become a scientist. Really, they were really cool, and so I wanted to be like them.
Can I ask, when you say lectures, is that a teacher?
Yeah, exactly. At the university. Yeah. But I also had some really cool science teachers when I was at school, and they made me really like science, and they made me want to go to university and study science.
How many times have you looked at a zebrafish?
Oh, many, many times. So we have a big aquarium at our work that has thousands and thousands and thousands of zebrafish in them. So there's lots and lots of different tanks. There's thousands and thousands of zebrafish, and there's all different types. And so everyone has different types that they look at. So yeah, lots and lots of times. But during a week, I probably look at about, well, every day.
What's science your best subject in school?
Sorry, can you ask it one more time?
Was science your best subject in school?
It was one of my best subjects, I guess, but I like lots of different subjects as well. So it's hard to say. I don't know. You'd have to ask my mum probably. She would know the best. I also liked, yeah, lots of different subjects. I like music and art as well.
Why did you pursue microbiology?
I think it's really cool. You can make lots of really cool images and really cool movies. You can see things inside a cell, which is pretty amazing, really, when you think about it. And you can see things that are happening every day in your body. You can see them happening underneath a microscope, which I think is really fun.
When did you decide that this would be your career?
It's hard to say because, yeah, it took a long time. For a long time, I just did science because I thought it was really fun. And then eventually, one day I woke up and it already was my career. Yeah.
What is your main focus with your team?
Our main focus, so the whole lab is trying to understand how an organ is made in an embryo, so in a developing organism. So actually no one really knows how for example, our stomach gets to a certain shape and size, or how our heart gets to a certain shape and size. Like, so the question is, how do the cells know how to make that shape and how to all interact together to build something of exactly the right shape and size that fits in with everything else in the body. So that's the main question, and all of us in the group are looking at different things and we're focusing on slightly different aspects of that question. And there's lots and lots and lots of work to do.
What kind of microscopes do you use?
We use actually a few different microscopes. So some of them are pretty small, and so that means we can just see the zebrafish eggs quite easily. But some of them are really, really big, which means we can see inside cells really easily. So they have to have a really big magnification on them, right? So that we can see things happening inside cells. Yeah.
What power?
How high?
What power? Yeah. So our little microscopes that we use to see the zebrafish eggs, they have a power of about 2 or 5. So we magnify it by 2 times or by 5 times. But the thing, when we want to see inside a cell, we have to look way, way, way bigger magnification for that. And so we have, usually I use 40 times. So it's 40 times bigger, but actually some people use even 100 times. So they're looking at things with 100 times magnification. And they can see really, really specific things happening. It's really amazing. Yeah.
Have you faced difficulties because you're a female in science?
Sorry, can you ask it again? I didn't quite get it.
Have you faced any specific difficulties being a female in science?
So not directly. So I've always worked with really, really cool people who doesn't matter. My first boss was female as well. So there's lots of people at the professor level now who are female. But there is, well, in fact, studies have shown that there is some implicit bias that I think everybody has, actually, women and men. It's not really different. You know, an implicit bias that people think that, or they have different expectations for women and men. So that's not something that I've necessarily noticed, but yeah, everyone just has to be aware of it, I think, because it's something that studies show us is still around a bit. Yeah.
Do you know any more of the functions of mitosis other than the basic 6 that we know?
Well, I don't know. What are the 6?
Go for
Interphase, prophase,
anaphase,
telophase. Okay, the stages. No, I don't. I think that's pretty much it. I think you've been well taught. Yep.
Have you discovered any new types of microbes?
No, I haven't. I'm sorry. No, I haven't. But we do often see them. So when we collect the zebrafish eggs, obviously they're in the same water that the parents are in, and often there's little things swimming around in the water. So when we have a look at the fish eggs, we can see little bugs floating around sometimes.
Have you discovered a specific type of cancer? And do you have any advice on how not to get cancer?
I've never discovered a specific type of cancer. I've just learned about what other people have discovered, actually. In terms of advice how to not get cancer, it's kind of tricky because there's lots of different types, obviously, and they're caused by different things. But I think probably a general rule would just be to kind of try and live a healthy life. And I guess you guys already know what that is, right? So like try and exercise a bit, eat fruit and vegetables, and not too much rubbish. And you know, even if you don't like sport, you can still find other things to do that you might like doing, like walking the dog or whatever. So I think that's probably pretty good advice in terms of staying healthy, not just with cancer, but with other things as well.
Have you ever had sushi?
Yes, I have. Have you?
Yes.
Yeah, okay. Yeah, I really like sushi. I think it's yum.
What's your favorite animal?
My favorite animal? I probably have a lot, but I think maybe my favorite, so I don't know if you guys can hear my accent, but I'm originally from Australia. And in Australia, we've got an animal called an echidna. Have you guys seen them? No?
No.
Okay, well, you should look them up and see if you can find a YouTube video or something. They're really, really cute. They're a bit like a hedgehog, so they've got spikes, but they have these funny feet that kind of point backwards, and it's so they can dig really easily. And so they're really they waddle around and they're really cute. And they're also monotremes, which is cool. Do you know what monotremes are?
Monotremes.
Monotremes? It's a trick question because the only monotremes in Australia. So, they're animals that lay eggs, but they still give milk to their babies. So they lay eggs like reptiles, but they feed their babies with milk like mammals. So they're a bit weird. So I think that would be my favorite.
How long have you lived in Australia?
So I was born in Australia, and I lived in Australia until I was 25, and then I moved to London. But I still go back to Australia like once a year or something and visit my family, visit home.
How long does it take for mitosis to happen in certain cells?
Sorry, can you say it again?
How long does it take for mitosis to happen in certain cells?
Oh, that's a trick question, because it can be really different in different types of cells. So some cells, it happens really, really quickly, like I would say even within 1 or 2 minutes, super quick. And then other cells, it can take like a really long time. And then there are some cells that stop doing mitosis actually. So actually nerve cells don't do any mitosis. So yeah, I can't give a very good answer, but even, you know, sometimes even in the same animal, mitosis can happen really quickly early in development when it's growing, and then happen really slowly later in development when, you know, it's already an adult. Sorry, that's not a very detailed answer.
How about the nerve cells she's studying right now? Someone asked about that.
Do you have any kids?
Oh,
No, I don't have any kids.
That's okay.
Thanks.
Anyone? Dr. Moore, the mitosis of the nerve cells that you're studying, what's happening with the mitosis of those? State or timing of it?
Yeah, so I'm, can you guys see my screen? If I show you a picture, will you guys be able to see it?
Yes.
Yeah.
Yeah? Okay. Let me see if I can do this.
We can't see your screen, right? We can't see your screen, we just see you.
Oh, okay. All right. Okay, I'll describe it. The group that I'm working with is looking at, so like I said before, how an organ develops and how it gets to the right shape and size. And we're looking at the nervous system, so that's the brain and the spinal cord, the central nervous system. And we have found a couple of different things that mitosis is really useful for. So one of them is that at first, all of the cells are really jumbled up together. And actually each cell doesn't, so they're like kind of like this. And each cell goes through mitosis, and each of their daughter cells, one goes to the left side and one goes to the right side. And so that means that the tissue gets really kind of symmetrical. So it's like this. Does that make sense?
Yeah.
No, not really. So if you have all of the cells like this, oh yeah, okay, great. So that's important to make the tissue symmetrical, because you know a lot of our body is half on the right side is the equivalent to what's on the left side. And another thing that mitosis is important for is to keep stem cells, right? So if you have a cell and it just turns into a nerve cell, then you don't have any more stem cells left. Whereas if the stem cell undergoes mitosis and one of the daughters becomes a nerve cell and the other one stays a stem cell to keep undergoing mitosis, then that then you maintain you've still got some stem cells left that can still make more cells later on.
Do you have any pets?
Yeah, yes. So I don't have any pets in London because I don't really have any room, but I have a pet. Well, I call him my pet, but probably my family at home would say he's not my pet and he's their pet. But his name's Arthur and he's a dog. He's not a particular breed, he's just a mix.
What season is it there now?
At the moment, it is what we call autumn, which you guys would call fall. So it's still the same season as you guys, I think, but it's coming to winter soon.
How about Australia?
In Australia, it is spring. Yeah, it's nearly summer. It's getting really hot. Yeah. So they'll have Christmas in the summertime.
The Christmas and summer. Did you hear that? Thanksgiving's in the spring.
Yeah.
I wouldn't have Thanksgiving because it's, you know, not the same country, but
Yeah, no Thanksgiving, but still.
Dr. Moore, can you explain about that you were talking about stem cells? And that's that's a new term for us.
Oh, sorry. So stem cells are cells that can become lots of different things. And usually they're special cells that even in the adult, they keep going through mitosis, even though you're in the adult. And so what's important about stem cells is if you get hurt, for example, if you need to, so you might need to heal something, or you might need some extra cells for something, they can start dividing and create some more cells through mitosis. So they do that through mitosis. So
What month and year is your birthday?
In March in 1985.
What kind of place do you work at? And like, do you work alone or with a crew of people?
Okay, so I work at a university that's called King's College London, and I work inside that university. I work in a department that's called the Centre for Developmental Neurobiology. So everybody in the centre looks at how the nervous system develops, and then I work within that. I work with a group of about 12 people, and we're the ones who are looking at something specific altogether.
How long does it take for cells to go through mitosis?
We kind of heard that one, right? We have to hear that one?
Yeah.
Okay, so similar question. Can we move on to the next one? Thank you, though, guys. Oh, yeah. What number are we on right now?
How do cells at the beginning of an organism decide which type of cell they will be?
That is a really tricky question. So there are a number of ways that this can happen. A lot of the times we don't really know. We're still trying to find out. But sometimes the cells will kind of communicate with each other. So they've got little receptors on the outside of the cell, and so they kind of talk to each other. And sometimes one of them will say, "Okay, I'm going to become this type of cell," and the other one will realize this and become a different type of cell. So sometimes they can do that, so you end up with the right numbers of cells becoming different things. And sometimes a big group altogether will say, "All right, we're going to become, the head or something." So in some ways they need to coordinate and do things together, but then at some points you need to make sure that different cells are doing different things. But yeah, that's a really tricky question. We're still trying to figure it out.
What animals have you studied on?
So I have studied mice first, and then I studied a organism called xenopus, which is a frog. It's actually a frog from Africa. And now I'm studying zebrafish.
Which one have you liked the most in your studies?
Oh, zebrafish.
And is that because you had mentioned they're transparent? You can see
Exactly.
the cell development.
Yeah. So because so I think they're better than mice because the eggs are laid, so you get lots and lots of eggs all at the same time. And they're better than the frogs because the frogs eggs aren't transparent, but the zebrafish are transparent. So it makes it really easy to look at things inside the egg as it's developing. So we can find out what happens in real life instead of just looking in a petri dish. And I have used a couple of different things as well, like chip, but zebrafish are definitely my favorite.
How old were you when you started doing experiments?
When I started to, sorry?
How old were you when you started doing experiments?
Doing
experiments. Oh, so I think I first did an experiment when I was at school, maybe about the same age as you guys, or maybe a little bit younger, looking at flowers and like dissecting flowers, and that was really cool. It sounds really silly, because they're just flowers. But actually, if you get a really nice big flower, you can see all sorts of things inside them. And then I started doing my own experiments when I was about 21.
Do you have some advice for future scientists and maybe the route they should be looking or things that they should be considering or thinking about?
Yeah, sure. So, well, I would definitely use science subjects and try and learn as much about them as you wanted, but I'd also just try and find out about the things that are interesting. Because you can find out, especially these days, you can find out about lots of things on YouTube and stuff like that. So you guys could go right now and look at zebrafish development movies on YouTube if you wanted, or whatever else interests you. And you can also find out how the things that or your subjects are related to the real world, right? So sometimes some science subjects seem a bit boring at school, but if you find out how they're important in the real world, then it becomes a bit more relevant. It becomes a bit more easy to understand.
So trying to get an idea of how you spend your day. Is your day mostly with a microscope? Is it mostly doing research, talking to people? Can you kind of give us an idea of your day?
Yeah, sure. So, there are a couple of parts to my job. So I do some things in the lab, and using the microscope and taking pictures, like making pictures of the fish, things like that. And then I spend some of my time in the fish facility looking after the fish, and making sure they're all okay. And then I spend some of my time in the office, and so that means talking to people, finding out what the other people in my team are doing, and if they've got good ideas what I could do, or maybe I've got a good idea for them to do. And also talking to other people in the department. So like I said, other people in the department are also looking at development. So they might also, and they're experts in lots of different things. So they might have a good idea, or they might not have heard about something interesting. So lots of talking to other people as well and finding out what's happening.
Do we have other questions from the group? Yes.
Are you in your office right now or at your house?
I'm in my office, yeah. What can you see behind me? Lots of folders.
If your house was like that, it'd be awesome. I want my house.
It would be a big house.
Yeah.
What other off-script questions do we have as we wrap up our time? Landon? To Mrs. Douglas.
Are you the leader of the team that you work with, or are you in charge?
No, I'm not in charge. So I have a boss, and he's in charge. But sometimes I help him by helping to teach some of the younger people who come into the lab. So we often have students who come in, and they always need someone to help them out when they first arrive. So sometimes I help him by kind of, being a teacher for them.
How long do you plan on staying at this university job? Is it something that you'll stay at for a while? Or?
Yeah, I hope so. So science is a bit tricky sometimes because you have to always apply for funding for your next job. But I hope that I can stay here for a little while longer because this is a project that I think is really cool and I really like it. And then hopefully eventually I will be able to get my own lab and be my own boss in Australia. And so hopefully I can move back home. But we'll see.
Yeah, what do you like about living in London?
Oh wow, well it's really cool. It's lots of fun. There's always lots and lots of things happening. There are lots of people from all different places, so that's quite fun. You get to meet lots of different people. And also, England's a really beautiful country, so you can do lots of traveling in Europe and in England really easily. So that's lots of fun.
Other questions?
Can you dab?
Can I what?
Dab.
She might not know that.
You know what dab means?
Dab?
No, I don't know what it means. Can you explain it?
Yeah. No, yeah. Okay. excited. Any other questions, Hallie?
Like, is there like a certain language in London?
Sorry?
There's a certain language.
A language?
Is it English?
English, yeah. Yeah. English is the main language, but because there are some different people, especially in London, there are lots of different people from other places as well. Often people will speak lots of languages, but the English people speak English.
Were you in London when the Olympics happened?
Yeah, I was actually. Yeah, it was lots of fun. There were lots and lots of people from everywhere. I didn't go to any of the stadiums, but there were lots of big screens in all different places around the city, and so everyone just like hung out and watched them on the big screen.
Last question, Mia.
If you were on a vacation and you could go somewhere, where would you go?
Oh wow, that's a tricky question too. Where would I go? If I could go anywhere in the world, I think I'd go to Antarctica. I think that would be really fun.
Well, Dr. Moore, we are in between classes. We appreciate
Okay.
you. Need a few minutes to get one class out and the other one in.
Yeah.
Thank you for your
You're very welcome. Nice to meet you all.
ready.
You're a trooper for doing this, by the way, because I know it's like, what, 10 o'clock there just about?
Yeah, no, that's okay.
You're awesome. I can turn off I'll turn off the TV while
Okay.
they switch.
Yep.
That way they don't come in like,
Yeah,
And-
sure.
And if you need to go get a drink of water or
Yeah,
whatever.
no, that's right. I've got a drink of water, thanks.
Okay. And then you can still see us, huh?
Yep.
How long do you think it'll take you to get them going, Bauer? So you'll be able to see them, but they can't see you, and we can't hear you right now. So, but I just want to let you know that you'll be able to see them, all the chaos of switching classes. I wanted to tell her, can you see the chat on the side if I open the chat? Oh, okay.
Alright, so boys and girls, as we get ready to do our Google Hangout with Dr. Rachel Moore, cell biologist, she's at a university in London. She's currently there now listening to us prepare and get ourselves in transition. We need to remember a few really important things. You're going to each be in charge of the question that correlates with your number in the classroom. So if you would look right now on that sheet, and share if you do not have one. Here you go. So look at the question and see if the question is already asked. A few of them get a little bit redundant. If the question has already been asked, feel free to ask something else. And also, if she has responded to something of interest to you, do not hesitate to raise your hand and ask a follow-up question. We don't have to go exactly from question to question. If she mentioned something in her studies that you would like to know more information about, just go ahead and put your hand up. Otherwise, we'll continue on. When it's your turn, please stand up when it's your number and know your question. So pre-read it and understand. You have to speak very slowly and with a lot of voice. So paper rattling that's happening right now that I can hear, we have to stop. So even if maybe you're already done with your question, then just get the paper out of your hand. Other kids were having a little bit of a difficult time with that because it's in your hands, and we're bodily kinesthetic people, and we tend to crumple up and hold things that are in our hands. So try to eliminate all noise that you can so that she's able to hear each question. We have to be quiet and respectful. She sees you on TV and we are filming this. So your behavior, again, is very similar to your digital footprint. When anything is videotaped, it's very similar to that record that's on print. So sit up, be present, be mindful. We talked about that this morning. Mindfulness is being in this moment, careful of what you do and say, be present with who you are. Joe.
How do we know which number we have?
You each were assigned a number in your roll call based off of your last name.
So like I'm 7.
I'm 7. I'm 7.
So I think she's in London right now. One of the questions is asked what time it is there, and you guys respect the fact that there is time difference. No. Okay, any other questions by scientists? So you want to try to keep distraction out of your hands and away from what you're doing. So backpack, just put aside, etc.
Will you like call a number or will we just?
She's online. She's been waiting for us. She's listening to us right now.
Hello.
Ready to go. So that kind of a thing, not okay. So turn your body around, be ready to go. All right. So I don't know exactly how to get you online. Why? Maybe he just turned the TV off. I hear him. He said he was going to be right back.
Are you ready?
Yes.
Okay.
Do this thing.
I want to see what her. You should introduce yourself too. You gotta like get in front of the television. Look at it.
I didn't want to, stand in front of these guys.
You gotta look up at that, otherwise she'll see your head.
Hi, Dr. Moore.
Hello.
So I'm Susie Bauer, and this is our second group of 6th graders anxiously awaiting to ask you questions. Thank you for your patience, for being here, and we really appreciate your time.
Thank you
You
for
could
inviting
give us an introduction.
Uh-oh.
Oh no, we lost your sound.
We lost the sound again.
Oh my gosh.
That's okay. Well, you're not muted, so maybe I'll do the re-invite thing again.
Yeah?
No, you're still quiet again.
Oh,
I'm pretty sure she's muted.
No, she's not muted. It would show her as muted right here, and she's not. You can hear us though? Thumbs up? Okay. Let me try the re-invite thing again. Does that work?
okay. Yep.
Okay, so close it out and I'll jump you back in.